Hello everyone, welcome again to my channel. Today I'm gonna show you software called Lusas. It's a Lusas civil and structural finite element analysis software that allows you to analyze, design, and assess basically all type of structures. Today, well, uh, all sorts of structures, doing linear analysis, second order analysis, dynamic analysis, basically everything. I would say is kind of like ANSYS. But today I'm gonna use Lusas to help you to build your Strut and Tie models. Basically, I like to use Lusas to, if I have the region or a region D, to know more or less what is the flow of the stresses, to see where the, I mean, if the section is complicated, if the section is not too complicated, it's easy to do it by hand. Section is a little bit complicated, well, it might be a little bit time consuming to define the different struts, different ties. And well, you know, if you have done this kind of strut and tie analysis, you know there is a iterative process. You keep checking, okay, you keep checking where the struts are, you change the direction, maybe diagonals, move them around. Well, it takes time. So to simplify the the calculations, not the calculations, but to obtain the diagram of forces, Lusas might help. In this case, I'm gonna just show you how everything is done with a limited version. It has some restrictions. This is a version for training purposes, but doesn't really matter when you apply this on a real case. You just need to increase the number of nodes and elements, and it won't be any issue. Okay, so probably if you have a full version, this window won't appear, or hopefully the window won't appear. And now we are gonna wait a couple of seconds. That is it. Okay, so it's still loading. You cannot see, but there is a loading window in my screen. So okay, we're gonna create a new model. We're just gonna give it a meaningful name. Let's call it Strut and Tie. Basically, you find the folder like every other single software. Then, well, it depends on what units are you working with. Then you will need to modify this too. I'm gonna leave it as it is. We're gonna do a structural analysis, not thermal, not coupled. Analysis category. In this case, I'm gonna show you a 3D element because, yeah, I think it's more useful. Or I think this is why you probably have come to this video to see a 3D something. So we're gonna, this is optional. I'm gonna leave it as a frame because we are not gonna analyze a beam or a shell. This is gonna be a volumetric element. And then, well, you can give it a title and a job number and whatever. Okay. So yeah, Lusas does like things. Oh, that's done gone crazy. Good. So first, how do we start with the model? We're gonna create a point. To create a point, we go here, new point. We use coordinates, easy coordinates to start with, so nobody is hurt. 0, 0, 0, global coordinates, fine. So that's our first point. Now what we're gonna create is a line from this point. So we select the point, then we're gonna go to sweep geometry, and according to this axis, I'm gonna create another point here. The other point here is going to be this one. So 0, 1, 0. You'll see that once I select the point, when I do sweep, automatically Lusas is going to say, oh, you want to generate a line. Oh, yes, very clever, Lusas. Good. So that has generated this line. Now what I'm going to do is to create a surface. So I'm going to select this line. I'm going to do a sweep geometry. And I'm going to give this now a translation in the X axis. Let's give it half a meter. And see, this has changed automatically to surface. So, okay. Now we have a surface. Now what I want to do is to do something similar. So I'm gonna continue the surface. You'll see why. I'm gonna do this in a second. So I'm gonna repeat the process. Do this, and now I'm gonna move this node upwards. So to move the node, let's just go here, move, and I'm gonna move it in the Y axis half a meter. You see where I'm going, what I'm gonna try to design? Yeah, basically it's an element that's gonna have a load here. Basically this is gonna be a column, and then with a load here. And you probably have seen this like a million times. Okay, so now what we're gonna do is to select this whole thing. We go back to sweep geometry, and then we're gonna create a volume. So I'm gonna give C1. See that as I have selected a surface, now Lusas already understands that I want a volume. Click OK. So this is the volume. For you to see, I'm gonna click here in isometric, and you can see here, this is the element that I generated. Now what we're gonna do is to mesh it. So first, actually, what we are going to do is to change the vertical axis. So we're going to tools, vertical axis, and we're going to say that the vertical axis is actually Y. But you can leave it as it is, it doesn't really matter. So for me, Y is this. Some issues rotating. Yes, I can do it. I can do it. It's stupid. Well, basically, this is the column, and this is where I'm going to apply the load. If I could rotate this somehow. Anyway, to rotate, what you need to do is to click the wheel of the mouse, and then with the right button, also click, and then you move around the mouse, and then it rotates. Good. So now we're gonna be working with this tab attributes. So we're gonna cover these elements here. With basically all of this, we're gonna be able to create a Strut and Tie model. So we're gonna mesh. What we're gonna do, mesh a volume. So let's go to the volume. So what are we gonna be using this volume? Well, this is gonna be used for stress. Then what type of elements we want to generate? Basically, I'm gonna generate the tetrahedral. No, actually, I'm gonna leave the hexahedral, but because if I leave it as tetrahedral, this is gonna generate a lot of lots of nodes, and with this version of the software, I cannot. It won't run. So I'm gonna work with hexahedral. Why? Because then I can remove this automatic. I know that with 4 divisions, this is not going to work, so I'm going to leave it as 3. And well, then what can you do? Apply a linear interpolation or quadratic interpolation. Well, this one is quicker, the quadratic interpolation. So it's more efficient. Linear needs a lot more elements to be accurate. So as well, I'm just gonna leave it as quadratic, so it's quicker. And I'm gonna leave the element name. That's fine. Okay. So as you see, nothing has happened here. So what we're gonna do is to select the whole element, and now here, our mesh is here. You see volume, but it hasn't assigned. If it will be assigned, this will be like colored. So we're gonna drag and drop. That's it. Easy as 1, 2, 3. What is not easy is to rotate it. But it's fine. Okay. So we have our elements already generated. What we're gonna do is generate a material. So we have this. We're not gonna work with this geometry. We're gonna go to material, material library. You can define your material, but for this case, we're gonna work with concrete. So it's gonna be concrete. I'm currently in UK, so I'm gonna work with this and with your code 2. Type of concrete, but let's say no. Well, it doesn't matter for this example, but let's say that we're working with this one. All the other properties are already defined based on the material and the code, which is fine. So we're gonna say okay. Then again, Lusas does something. We select this and then we say okay, we want to apply this one. Same with drag and drop. Assign to volumes for the analysis one. Okay. So as this is color, all of this has already the concrete properties. Good. Now we are going to generate some supports. So to generate the supports, let's generate them here. So we select this surface. To select the surface, you press Shift and then S. And you're here, support, and I'm gonna leave them as pin. Actually, I'm not gonna use this. I'm just gonna drag. See this? There's here already pin, fully fixed, fixing, whatever. So I'm gonna drag the pin and assign them there. Assign to surfaces, yes, perfect. So those are my supports. So that represents that whatever I have a column basically here, so this cannot move. Actually, they could be fixed, but well, as there are so many pin supports, it's like this fixed. Good. Now we're going to define the loads. To define the loads, we're going to go again to attributes, loading. I'm going to apply global distributed. I don't want to apply the loads on a face, or there are like millions of types of loads that you can apply. Temperature, stress and strain, distributed to perimeter, fine. We're not working with velocities, acceleration, displacement, so you see this very powerful software. So I'm gonna go next, then I'm gonna define the load. This is, if you remember, the units were in newtons, so I'm gonna apply basically a kilonewton on a surface. No moment, just a vertical load. Nice and sweet. Okay, so this is total. So the total load applied to the surface is going to be 1,000 newtons or 1 kilonewton, but you could define it as a UDL or surface area, whatever. Okay, finish. Then you see the load here is this one, the one that we have just created. In doubt, no, actually this one. Double click, appears there. So again, we click on the surface that we want to apply the load. It's going to be there, and then we drag and drop. Single load case assigned to surfaces. This is our only case. That's fine. Okay, so that's it. Our loads have appeared there. You'll see that there are some arrows pointing down and some arrows pointing up. This is how Lusas works and apply the forces. It needs to it applies some forces on the they are not nodes, but at the midpoints of the quadratic element, and then it has to apply some other forces that basically counteract these forces, but the overall force applied is 1,000 newtons. If you want more detail, go to the manual, but basically it's just how I'm not 100% sure and what is the principle behind that. It has to apply some kind of reaction forces to generate the force that you're applying, but it's how it works. Good. So we're gonna go to solve. It's gonna ask me to save. So we're gonna solve this analysis. It says needs solving, no results on this. Save model. Fine. So you cannot see, but it opens another window that shows the solution and everything. So this is it. This is what happens when you apply 1,000 newtons to this concrete element. Of course, this is super deformed, so this is not a real deformed shape. So we're gonna tweak this a little bit. So we go to layers, we go to deform mesh, and then we're gonna say we're gonna reduce this to 5, apply. Okay, this looks a little bit, but it's not reasonable, still way more deformed than what it should be. But you get an idea of that. Well, what you have done is appropriate, or looks correct, because well, this is what you should expect while applying a force there. Good. So what I'm gonna do actually is to disable this. I've right-clicked and I don't want the deformed mesh, because what I want are the stresses inside the element. So I can do a couple of things. I can go to contours. You can check stresses. SE means principal stresses. Let's show this averaged and apply. So this is it, and in the principal, showing principal stresses. But again, this is not what we were looking for. What we were looking for were the strut and tie things. So we're going to go to vectors. Then we want to plot stresses, principal, average, nodal, or Gauss points. It is a little bit more detailed, the Gauss point, because it generates like intermediate points. So it's a little bit slower, but with computers nowadays, that shouldn't be an issue. Then for vector display, I'm going to remove the arrowheads and I'm going to scale it a little bit more. And that is it. So red means tension, blue means compression. As I'm applying, can I do this again? Oh, God's sake. Thanks. I should have done like 10 minutes ago. So stupid. Okay. So as you can see, the force is applied here, the compression is going here, and of course there's some tension generated here. So while building your strut and tie model, this is obviously is a very simple case, so you probably won't need to use this to know where the compressions are going and the tensions are going. But what is interesting here is not just the principal lines. You know that you can see here that there are small red lines. So that means that in this direction there is compression, but in the perpendicular direction there is tension. So that means that, of course, this compression, so your reinforcement should go all the way up here. I mean, theoretically, you won't need reinforcement here because the tensions here are minimum, but of course you cannot go from here to there while defining reinforcement in a concrete section. So we'll go from here to there, and then you also need reinforcement here. That will be your links that are tying up. At the end, you're gonna have reinforcement around here, 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 going down. But also, you need reinforcement in this direction. And what is telling you that you need reinforcement here are those links, these little red lines that are telling you that there's tension going in that direction. So that's it. I hope you enjoy. You put this in good use. You apply it to a lot more complicated cases. Let me know in the comments if this has been useful for you, and I'll see you in the next video. Bye.